Okay, all right. First, here's what we have. Section 3. We've done the last two. If you don't remember the last two sections, the first one was based on expressions. Could we write, a sentence into algebraic form into a word sentence? Second section was the order of operations, PEMDAS. Third section, now we're starting to see the properties of algebra. The real basic ones, the real stuff that most people don't even think about doing. Before I jump right in and start telling you all these property names, this is what I like to do. In your little pot, each of you need a piece of paper out. We're not going to turn this in. Just have a piece of paper out. You can have it in your notes. Here's what I'd like you to do. I'm going to put a problem on the board, and I'd like your group to try to figure it out and just discuss the answer. And it's going to be very short, very simple, very sweet. So here we go. Okay, now here's what I would like you to try. Try to do it without a calculator. Now I know that seems like a wicked thing to do, but I want to see if you can take a few minutes to do this, and then we're going to discuss it, like how did your group, how did your little pod approach it without a calculator, okay? That's all I want you to try. I know it seems silly, but trust me today, this is something you want to know because it makes your life a lot easier once you see the rules. I'll give you 2 minutes. Let's see what you can do in 2 minutes. Try out your little pod. I'm just going to call out random groups, kind of see what you have. But try it without a calculator. I know that seems a little silly. As I take a I know, I already got my answer. I'm not seeing if that's right.
What if we think you have
We can change it.
Okay. No, I'm not going to change it. I'm just seeing if it's right. Got about another minute.
I need that.
Anyway.
Is that right?
No calculator. No calculator.
I was
checking to see. Okay, alright.
Yeah.
Cool.
It was written right there.
Sure.
It's on there. It is written.
Dang it.
What four is that right?
Lead pencil.
210, yeah.
They get so easy.
We're out of calculator.
No, I didn't look up it. I just checked it.
And what'd you get?
That's cheating.
I had the same answer.
Did you get 210 times 14?
I had it before and I just checked it because I figured it out.
How'd you get 2?
How'd you get 210?
Okay.
I didn't know.
Alright. Alright, so we're up on the minute here. Alright, so here's the idea. I'm going to call on a random group. Let's just see what our answers are. So, answer? 210. Did anyone get a different answer other than 210?
AJ?
No.
AJ, what answer you get?
164.
164? Okay. Alright, I'm going to write them both down. Okay, we'll kind of check which one I'm not saying right or wrong. So we got a 210, we got a 164. Anyone else get any other answers other than that?
190.
190? Okay, alright. Any other answers?
What? What's
Okay.
the right one? 210?
Alright, let's walk through and figure out which one, if these three are even correct in the first place. Okay, one method. Now, it could be up to you how you do this. One method you could do is just go left to right. Order of operations. You could do that. Right? That would actually be what most people would attempt. 3 times 5 is 15. Then you take that times 7. And 15 times 7, I don't even know what that is. I have to write it down on the, yeah, so that's 35, carry the 3, and you get 105. And then you double it, which is 210. So it looks like 210 is the right answer. Now, here's the thing. Would you agree that took way too much work?
No, not really.
I'd say it does. Because if you get lost in the middle of like 15 times 7, you have to go, I don't know what that is, and you're trying to figure it out. Here's the idea. It is 210. There is another way to attempt this problem.
Can you do it on the lattice method?
By what?
A lattice method?
Lattice. You can do lattice, yeah. You can do lattice, and which would be 210, correct? Okay, all right. Now,
I split 2 up to 3 times 5 and 7 times 2 and then times 15.
okay, so now we're starting to see different strategies. 3 times 5, the 7 times 2, so you get 15 and 14, and then you multiply these together, and got 210. That's another strategy. I haven't heard the right one yet, though. It is a strategy and it works. Here's the thing. To do this in your head without the need of a calculator, instead of just going left to right or grouping things together, which you are correct, all of you have a good strategy that you're doing.
3 times 5 times 2
I have another one, sorry.
Okay.
Say it.
So.
Yes.
You go from the middle out.
Say it again.
You go from the middle out.
Middle out. Okay, you can do that. So you go, this is 35, and then take it times 3 and times 2. Kind of go middle outside. Okay, you could do it. That is a strategy. What else?
3 times 5 times 2.
Okay. So now you're starting to, okay. So what you're starting to hear here is you're starting to go out of order. Okay, 3 times 5, then times 2. And the thing is, you're actually onto the strategy that I'm talking about. You can actually go out of order on this problem. I know that seems silly because I just went through 3 days. I just went through 3 days of order of operations telling you the order you have to go in. But do you agree that all of these are multiplication?
Yes.
You can go in any order you want. In fact, this is one of our first properties we're going to talk about. You didn't even have to go, 3 times 5. You can actually move these things around, and the easiest strategy is to do this. Is to move the 5 and 2 together, because that makes a nice 10. And when you multiply by 10s, you just put a 0 on the back of numbers. That's literally what you do when you multiply by 10. So when this turns out to be 21, 3 times 7, and you take that times the 10, you just put a 0 on the back. And now you don't need a calculator anymore. When you start thinking in terms of like 10s. This is a strategy, and in fact, you were on it, right? Reese was saying that he did 3 times 5, then times 2, because he knew he was going to get a nice number. He was getting 30, and then he was taking 30 times 7. Because he went 3 times 5 times 2 times 7, and this turned out to be 15 times 2, which he knew was 30. And that is an actual strategy, which is a lot like mine, where you don't need a calculator because you're picking numbers that you know in your head. Because 3 times 7 is 21, and you add a 0 on the back. That's the strategy for multiplying 30 times 7. It's this weird idea that you can go out of order from the order of operations. So here's your property. Okay, here's your properties we can go through. Okay, these are the two I'd like you to write down. They're right down here. They're called associative and commutative in no particular order. These are the two main properties that will help you do an algebra problem so that you don't need a calculator sometimes. It'll actually make your life a lot simpler when you know these properties, because it makes problems in such a way that you can do most of the numbers small digits in your head, and then you can just learn little tips and tricks for how to like multiply by 10s or multiply by 2s, that type of thing. But I have the descriptions of what they are. Commutative is when you change the order of your problem, but it doesn't affect the final answer. You can actually switch order. That works in only certain types of operations. We're going to talk about this here in a minute. And associative is when you change the grouping symbols around. We haven't seen one of those yet. That's the next example I want to see that you try.
What?
All right, so do we have both properties written down, associative and commutative? Okay, the commutative is the property we just did. This is called the commutative property. When you commute, to commute is to, if you ever heard the word commuting to work, means you group and you move, right? You group up with your people and you move to a new spot, right? Like when your friends get in one vehicle and then you go to wherever you're going, the football game or basketball game or wherever you're going. That's commuting. You're grouping and moving. That's what you're doing here. This idea that we can do this for any type of math, like this. This is just an addition problem, right? That I can take that problem, 4 plus 3 plus 7 plus 6, instead of just going left to right and trying to figure, okay, what do I get? I get 7, I add a 7, then I add a 6, and you're taking too much time. You're allowed to take that problem, this problem, and move the order. So I can move the 4 and 6 together, I can move the 3 and 7 together because this is all addition. This makes 10, that makes 10, and so we're getting 20 in the long run. Some people can do that in their head, left to right, really quick, but if you group it, that's a strategy that I don't need a calculator. I don't need to go left to right and waste time. I can group things. Now notice, it's working for addition or multiplication. I did not say subtraction, and I did not say division. It doesn't work for those. It only works for these two. Now, this is a multiplication problem. This is one that you just did a little bit ago. You can move the order around. 3 times 5 times 7 times 2. I just grouped them up. I rearranged the order. I grouped and moved. And then I can complete the problem as I will. I usually try to always go to tens, multiples of tens. When I'm adding numbers together, I also try to get to groups of tens. That's a strategy you use. That way it's easier to add in your head. Some people have different strategies for adding. Like if I was adding up this class's total, I go by 2s. Some people go by 5s. They look at the groups in the room, they go, okay, this is 5 people, there's 5, and there's another 3, so there's 13 in this room. Right? But I usually go by 2s. That's a strategy. It's a commutative strategy. You're grouping and adding really quickly in your head. Or multiplying in this case. Does that make sense, the first property? Okay, here's the next one. Okay, here's the next problem I'd like you to write down. And I want your group to try it without a calculator again. Without a calculator. So, here we go. Okay.
Oof.
Oof. Try it without a calculator. Without a calculator.
What's Google when you need it?
Yeah.
You said without a calculator.
Without a calculator.
Google is a calculator.
Is that decimal?
It will not be.
Come on.
But you can't do this with 32.
Okay, this is an example of the next property, which is called associative.
I'll check it.
Associative works on multiplication and addition. That problem, do you agree that problem is all multiplication? Okay, they have the time symbol inside the parenthesis. They have that number on the outside of the parenthesis. It's all multiplying. Here's the idea. If you know this property I'm about to show you, you didn't even need a calculator. The answer is 46.
What?
Here's how. Okay? Here's why. If I just get rid of the parenthesis bars, that's a grouping symbol. I can get rid of the bars. They're all multiplying, so it doesn't matter that I use the parentheses or not. I know in order of operations you have to do things inside the parentheses first. But if it's all multiplying straight across, you don't need to have the parentheses there. That's a grouping symbol. So when I do this problem, I do 5 times 2 first, which is 10. And when you take it times 46, one of the rules when you multiply by 10, instead of adding a 0 to the back, it just moves a decimal back. That's what tens do. So I move the decimal back and your answer ends up being 46 with the decimal after it. That's a trick for when you multiply by 10. Because here's the idea. When I did that problem earlier, when I did 21 times 10, I did kind of lie to you a little bit. Instead of just adding 0, what it's actually doing is moving the decimal back one spot, and you're just filling in any gaps with zeros. Well, in this problem, I didn't need to fill in any gaps with zeros because when I move the decimal back, it puts it behind the 6, and you have every number accounted for. That's why this answer was 210 earlier, and that's why this answer is 46. It's literally moving the decimal. When you multiply by 100, let's say this was 50, and you get 100 here, you'd move the decimal back 2 spots, so it ends up being 460. You just keep moving the decimal every time you have another 0. It's one of those weird rules, but unless you saw it, most people wouldn't know that you could do that for multiplication. You can get rid of the symbol and then move things around and go from there. Now it also works on addition. So on a problem like addition, where I'm doing something like this, I'm doing something like that, and I don't want to just do the middle numbers, then add the front, then add the back, that's silly. These are all being added anyway. You can get rid of the grouping symbol. You can get rid of the grouping symbol, get rid of the parenthesis, and then just add left to right. This ends up being 10 plus 10, which ends up being 20. But going out of order, it would take you longer than just seeing that you can do that property and get rid of the parentheses bars. But again, notice, associative is, when I hear the word associative, I think parentheses. I remember how to spell it, it's parentheses. There we go. That's what I think of, I'm getting rid of the parentheses bars. When I hear commutative, I'm thinking grouping and moving, commuting to work, right? Group and move. But again, it only works for addition, multiplication. Do we understand the two properties now? The idea behind them? Kind of weird stuff, right? You can do a lot of this math in your head as long as you can do simple numbers. That's why the calculator is great, but the thing is, like, if you just totally rely on a calculator the whole time, you're actually too slow on the matter of properties that we're doing. Okay? All right. I have a couple examples here that I'd like you to try. In your group, I'm going to call in different groups for different problems. If you need to go grab a calculator, go get one right now. You're going to need it.
Never have given one.
Might be helpful to do some calculator. Use a calculator. Darg, welcome back. You just missed a couple of properties. So here's what I'd like to do. When you get a chance, write down these two names here. Commutative and associative when you get a chance. And we'll try to fill you in what you missed.
Okay, someone will call. Someone will call.
I think Darg, I think you're still here. I think it's right. Yeah, so commutative and associative, write those down. I'll try to fill in the best I can. Mr. Darg. Okay, everyone get a calculator that needed one? Okay, so I'm going to give you a couple examples of these properties. I'd like your group to attempt them. Now, here's how I know you have a calculator in front of you. I want to see if now that you know my strategies, can you attempt these problems without the need of a calculator? Now, if you need one, fine, Danny, type it in. But try to use it as little as possible. Okay? That way you can use it to kind of check your answers. But again, we're going to try to go through these two properties for these next couple. So here we go. Okay, so here's how I like. I'm going to assign your group a specific problem. Group 1, you guys have letter A. Okay? Just write it down. We'll come back to it here in a second. Group B, you have group B. That's that group back here. C, D, and E. Okay, all I'd like you to do is write down the problem. That's all I want you to do. So A, B, C, D, and E. Now, I know this seems silly. I'm giving you both sides. What I'd like you to try to figure out in your group, imagine that this left side here, this is your problem that I gave you. This is your problem, okay? They did something to make it this side.
Yeah, they switched it.
Okay, they switched it, they moved a parenthesis, they did something. It's one of the two properties we just did. It's either commuting, that means grouping and moving, or it's associative where they move the parenthesis bars, or they get rid of them completely. I want your group to write down what property they did from the left side to the right side. That's all I want you to do. That way we're getting a sense for what property is which. Okay? I'm going to give your group 2 minutes, figure out what the property name is, and you're going to explain why. Okay? If you want me to double check your answers, I will look it over just to make sure that you are correct or not. Okay? I'm going to disagree.
Well, right?
No, I don't have the answers.
You didn't even do it.
I want to know. I want to do it from this side to this side. They did something to your property for the commutative, so actually.
This was making noises.
Okay, again, once you have your property name, I want to double check it. Okay.
Yeah, that's exactly.
What's your? You're right. It's
Now I'm paranoid.
still starting on.
It's because of this.
I'm not sure.
Everything you said there was. That's what I checked. Okay. Anyone else want me to double check? You just erase it. That letter C, right? Remember, all your goal is not to find the answer, is just to write down what property did we do. The next couple of problems we'll try on an actual example. All right. All right.
I gotta get this.
Okay, are we ready? Has everyone had a chance to do this? Does anyone need me to double check your answers? I think I checked most groups. Okay, I'm gonna call on you, and all I wanna hear is the property and why. Okay, all right. Hey, so if you are not letter A, that's fine, you can pay attention because, again, I want you to get these. All right, letter A, group one here. What properties from the left side to right side?
Commutative.
Okay, this is commutative. Why?
Because there's no practice.
No parentheses, number one, so duh, had to be commutative, and what else?
Because they just.
Yes, they just switch numbers around. When they just switch the numbers, the order, that's commutative, so they're absolutely right. Okay, so that was very good. All right. All right, stop that. Okay, group B, back here, this is the far group. Say it again. Associative, why? Yeah, they move the parentheses. So if you notice, they had the parentheses around 6A, and on the next step, they moved it around the 3 and the 6. They didn't switch the order of the numbers 3, 6, and A. They just moved the parenthesis bars to a new spot. That's one of those things you just got to notice on a problem where they're doing something like this. And we have a parenthesis bar, and suddenly in the next step, they move the parenthesis bars around the 5 and 7, and notice the 3, 5, and 7 and 4 haven't moved, just the bars, that's associative. Okay, that was good? Okay, group C, associative, why?
Because they move the sentence.
Yeah, they moved the parenthesis bars, notice. The 4, 6, and 8 stayed where they were. They stayed from the left side to the right side. They just moved the parenthesis bars to around the 4 and the 6. Because again, that's just a movement. Okay? Group D. What do we have? Commutative. Why? Yeah. If you notice, inside the parentheses, they switch the numbers. This one's probably the hardest problem of all 5. Because it looks like associative. You're thinking, oh, it's got parentheses, it's associative. But they didn't move the parentheses. They moved the numbers. That's associative. That's commutative. That's commutative. Because they move the numbers around. Now, why they did that is because they're going to move the 2 and 10 next to each other on the next step. That makes it a lot easier to look at. All right, next one. Last group. Letter E. Say it again?
Commutative.
Commutative. Why?
Because they just switch the numbers around.
Yeah, they switch the numbers. Left side to right side. And what are they also missing on this problem?
Parentheses.
Yeah, they have no parentheses, so it can't be associative. They don't even have parentheses in the first place. So that's pretty easy to spot. All right. Are we ready to go here?
Sure.
Okay.
Wait,
All right. Here's what I'd like you to do. On this next group, okay, this next problem, your group is going to try to figure out, I'm going to give you 5 problems on the board. 5. I want your group to figure out which ones are using commutative. That's it. That's all you're doing. Every group. Which problems out of the 5 I'm going to show on the board are using commutative. That's all I want your group to figure out. Okay? All right, here we go. So next step. So I got 5 problems. Your group needs to figure out, did they do commutative and which problems did it? The left side to the right side. Just so, when I ask in your group, you're going to say, okay, problem number 1 did it, problem number 4 did it, problem number 5 did it. Something like that. I'm making that up. You're looking for commutative only. So again, if you don't remember what commutative is, that's where they're switching numbers around. You know, it could be something like this. And maybe you switch the 2 and 3 around on the next step. They're flipping the numbers. That's commutative. The numbers switch from left side to right side. Okay, figure it out. I'll give you a minute.
That's it.
Is your birthday?
Yeah, because I didn't even know one parentheses, they just swapped out.
Is your birthday?
So try to figure out which number or numbers.
Ben.
That's right.
Ben. Ben. What? So it's super serious, right? She was fun.
Because all the numbers.
She had full on.
You guys started farming?
Remember, you're telling me which numbers they're doing commutative on. That's all you're trying to figure out. Okay, we got about 30 seconds left here. 30 seconds.
Says you.
All right. Okay, here's what I'm gonna ask for. I'm gonna ask for a group to volunteer,
Look at myself.
and all you have to do is tell me one of the numbers you know is doing commutative, just one of them. Okay, please, give me one. Number one, okay. I agree with that. That is definitely commutative. Why? What move? Which numbers? 7 and 16. They switch. Okay? Now, give me another number.
5.
5. Okay, why? What move?
Because they switched the numbers.
Yeah, which numbers?
7 and 3.
7 and 3 switch. Last group?
I got one.
Number 3. Okay, they switched the 5 and 2 around.
No.
Okay, the parentheses stayed, just the 5 and 2 switch spots from the left side to the right
We were
side.
using the.
That's commutative. Okay, they're gonna probably group things together here. That's why. Let's stop the whistling. Put off, please. All right. Okay, now that also means that on the next property, associative would be number 2 and 3, because they moved the parentheses bars. They didn't move the numbers, just the bars moved. Because maybe on this problem it was easier doing the 20, and then 20 times 13 might be an easier number. On this one, it might be easier adding these numbers.
I would have.
Sorry, it's easier on this problem adding the 9 and 11 together than it was 16 and 9 and going adding 11 later. Even though those are kind of easier numbers. Okay, again, do we feel comfortable with those two properties? Okay, this is my last slide of the day, last slide. Okay, here's what I want. I want your group
That's all I need.
to figure out which property up here, which properties are the commutative property of addition. So A, B, C, D, which property, which A, B, C, or D, or maybe there's a couple or one, which one is the commutative property of addition? I'll give you a minute, this is my last slide today, and we're gonna talk about why. Why did they do it? What was the purpose of doing it? The commutative property of addition.
Hey, my career. Huh?
C has subtraction, so I can't.
When I told you.
This is my last slide of the day.
But
Yes, Yes, my cutie.
Okay, now again, it could be more than one, it could just be one. I just want to know which one up there, or ones, plural, if need be, are the commutative property of addition. Okay? Alright, can I get a group to volunteer? Alright, Sam, what do you guys have? B? Okay, alright, let's start with this. I'll agree that it's definitely addition, the whole entire problem. But why is it commutative? Why do they commute?
They switched around the 14.
The 4 and 3, okay? Now, here's the idea. To me, it's easy to spot commutative addition because they're just adding numbers. It doesn't matter the order you add, you'll get the same number every time. Now, why they're doing that? Maybe in the problem, the problem was this to start with, and the next step was that one, where they moved the 3 and 7 next to each other. That will make 10. Maybe that's what they're doing. Or maybe they just felt more comfortable adding the 7 and 14 to get a bigger number first. Okay? Alright, now, let's talk about why the other properties are not the addition property of commutative, right? Why is this one not commutative property of addition? Looks like there's that. They just move the parentheses. That's actually associative. Why is this one not?
as minuses.
Yeah, they have a subtraction symbol, right? Can't be addition. And the last one.
Has one more number on one side.
Yeah, they don't even have the same numbers. Can't be commutative when they switch the numbers around. All right, is there any questions why it was letter B only? Okay, we're done for the day.
Oh, no,